All right, hey there, it's your old pal Mr. Cook, and we just finished up 6B. That's doing Gauss-Jordan elimination, where we go all the way down to an identity matrix. Now, these last couple of problems are like real easy as a result. You're gonna love this. This is so simple. Find the inverse of the following matrix. So with a 2 by 2 matrix, it's really easy. It's just a formula, and here's how it looks. The inverse of a 2 by 2 matrix, so only 2 rows by 2 columns. The inverse is found in the following way. It's going to be 1 over the determinant of the A matrix, the one that you start off with, and then times, and here's what you do. Ready? You switch the A and the A and the D value gets switched, okay? So it becomes D over here and A over here, and then you negate these two numbers over here. So it's called negative B and negative C. So if you do that, that's how you can find a quick 2 by 2 matrix determinant, or sorry, inverse, and it's really easy. So let's follow this and the structure and solve for the inverse of the matrix. So we do 1 over the determinant of A. So how do we do the determinant again? So it's the corner numbers and multiply them together. So 4 times 4, and then minus, and then it's these two corner numbers, 7 times 2. All right, so that'll give us some number. And we're going to multiply that onto our new matrix, okay? So we take our matrix, that we have over here. This is A and B and C and D. So we switch the A and the D value around, which actually isn't going to do anything. They're both 4s, so that doesn't change anything. And then we negate the B and the C, so that's going to turn into a -2 and a -7. Okay, we are so close. I can't even believe it. So let's find out what this number is right over here. So I'll do that off to the side here. Here's the algebra for it. 1 over, and then 4 times 4 is 16. 7 times 2 is 14. And 16 minus 14 is just 2, so a half. So this whole thing just becomes 1/2. All right, and just like any scalar, I just distribute it into all the different terms in here. So I get, 1/2 times 4, so that'd be 2. 1/2 times -2, which is a -1. 1/2 times -7, which is -7/2, and then 1/2 times 4, which is 2. So there you go. There's your inverse matrix. It's that easy, and that'll do it. There you go. So you're all done. So now check that A times A inverse is equal to A inverse times A, which is the identity matrix. All right. Well, I'm going to write them up so they're a little bit separate from each other. So I can do the multiplication real easy. I need to give myself a little bit of space because, as you've seen, multiplication, can take a little bit of work and a little bit of time. So we've got 2, -1, -7/2, and 2. Okay, there we go. All right, here we go. Let's start with the first one, A times A inverse. We're trying to show that this is going to be equal to the identity matrix. And the identity matrix is like 1s diagonally and then 0s everywhere else. So in a 2 by 2 case, it would be like this. It'd be 1 and then 1 across the other diagonal and then 0s everywhere else. So like that. That's what it's trying to look like, okay? All right, so here we go. Let's do A times A inverse. So A is going to be 4, 2, 7, 4. A inverse is the other one, 2, -1, -7/2, and 2. All right, so let's multiply this stuff together. So it's rows times columns. So it's going to be a 2 by 2 matrix when we're all done. So, let's write those out here. And let's see what we end up with. It should be 1, 0, 0, 1. Let's see if that's the case, okay? So let's see. Row 1 is 4 and 2, so 4 times something plus 2 times something. And then row 2 is 7 and 4, so 7 times something and 4 times something. Oops, I don't know why I wrote a 0 there. I also don't know why I wrote my 4 all weird. So 7 and 4. All right, and then now we've got column 1, which is 2 and -7/2. So 2, -7/2, and then 2 and -7/2. And then column number 2 is -1 and 2. All right, let's see if we end up with the stuff that we want here. So the first one is going to be 8, and then 2 times -7 is a -14 over 2. And that's 14 over 2 is 7, right? So 8 minus 7, yeah, that's 1. All right, so we're good to go so far. Got the first one. Let's see, this should be a 0. Let's prove that that's the case. 4 times -1 is -4. 2 times 2 is 4. Yep, 0. Okay, so we got that one. And then let's see what we've got here. So that's 14 plus, and then 4 times -7, that's -28, over 2, that's -14. And 14 minus 14 is 0. Yeah, that's good. So this one's good so far. And then the last one, -7 plus 8. Yep, that's +1. Okay, so this one checks out. And then what we would do is we'd switch the order and see if it gives us the same thing. And then after that, like this last problem is like super easy. So A inverse first. So 2, -1, -7 halves, and 2 times A, which is 4, 2, 7, 4. So it's going to be another 2 by 2 matrix, which is good because, we need it to be 1, 0, 0, 1, right? We need it to look like this. Let's see what happens. Okay, so on the left, it's the rows. On the right, it's the columns. So 2 times something minus 1 times something, and then 2 times something minus 1 times something. And then the bottom row, that's -7 halves times something plus 2 times something. And again. And then the columns, so 4 and 7, that would go in column number 1, 4 and 7. And then 2 and 4 for the other one. And, you'll be able to show it. That's 8 minus 7, so that's 1. That's 4 minus 4, which is 0. And then that's -28 over 2, which is -14. And then plus 14, which is 0. And then, let's see, -14 over 2 is -7 plus 8, which is 1. Yep, so both of them are equal to the identity matrix. So there you go. All right, one more problem, and we are all done with, this group work assignment. And this is pretty easy. You use the following matrix equation, and the coefficient matrix is inverse. So they give you the inverse to solve the system. So watch how easy this is. So this is basically like saying that A times X is equal to some value B, right? So if I multiply by the inverse over on this side, and I multiply by the inverse on the left-hand side of B, then this just turns into the identity matrix, which is like essentially like a 1. So all I need to do is this. Ready? To solve for X, you just take A inverse, so this matrix, and then multiply it times B, which is this. That's it. It's that easy. So watch. Let's do the multiplication for it. So we take the inverse matrix, 4, 1, 5, and then -4, 1, 4, and 5, -1, and -6. And we multiply that times the B value, the solution, which is -1, -7, -6. And whatever we get here is going to give us X, which is the, this part right here, X and Y and Z. All right, so let's see what we get. Here we go. And watch, the dimensions will match up. This is 3 by 3. This is a 3 by 1. So since these are the same, they'll multiply. And we'll end up with a 3 by 1 matrix. So it's going to be 3 rows and 1 column. So let's do our little 3 rows here and 1 column. There we go. So let's see what the numbers are going to end up being. Okay, so, the matrix on the left gets broken up into rows, and then we only have 1 column, so that's going to be pretty easy. So it's going to be -4 times something, -4 times something, and then 5 times something. Looks like I'm not going to need that much space. Okay, and then it'll be 1 times something, plus 1 times something, -1 times something. And then 5 times something, 4 times something, and -6 times something. All right, and all those somethings are just going to be this like one individual column. So we do -1, 7, -6, -1, 7, -6, and -1, 7, -6. All right, and then it's just up to you to use a little bit of algebra, and you've got your solution. So 4 minus 28 and minus 30. Oh, Lord, that's like a huge number. Good Lord. But did I do that right? 5 times negative 6. Oh, that's a negative 7 in there. Darn it. Okay. Sorry about that, guys. You probably were like, Mr. Cook, come on. And you were right. I should have known better. So 4 times 28, 4 plus 28 is 32. 32 minus 30 is 2. So 2 is our first number. Then after that, I've got negative 1, and then minus 7, and then plus 6. So negative 8 plus 6, that's negative 2. And then the last one is going to be negative 5, and then minus 28, and then plus 36. So that's like negative 33 plus 36. So that'd just be a positive 3. See, when I put this together, or, I don't even know if I put this one together, but it's like easy numbers. So make sure you get some easy numbers at the end, and that's it. Okay, that's all I'm going to do for this video. I'll probably make like the extra practice next and post that. But that's the end of this worksheet. Good luck on your test. Get some help from your teacher or whomever. Yeah, that's it. See you later. Thanks for watching. Bye.